chicken kitten.
She's back.
It's in my homework. It's in my homework. It's for me.
Like and subscribe. You guys need your water, you got me sick.
Actually, you not plug your computer and put it away to start on the investigation from yesterday?
Butter them.
Nope. In 2 minutes. One more minute. 30 seconds, actually. It's hot. I need a paper. Alright, finish up. Chickies. Third place, Geraldine. Second place, Carla. First place, Tamia. First and second period always have all boys. This class has all girls. Interesting. Nice job. Put your computers away. Thank you, Manuel. Thank you, Tamia. Thank you. Lindsay, thank you. Abel, thank you. Everyone. Great. So we are on day 2, or lesson 2, day 2 of 4.02. Okay. We are talking about and learning about how to represent quadratic and linear functions using tables, equations, and graphs. And through the language of compare and contrast, we're going to talk about their similarities and their differences. This is what we are working towards, laying the foundation for, right? All of this new quadratic stuff, there's a lot of it. So we're laying the foundation of linear and quadratic patterns so that we understand how the rest of this works. We see quadratics everywhere. You will find them useful beyond this class. So now, everyone needs to have the investigation in front of them, 4.02. There are some notes from yesterday that I've left on the board talking about the differences between tables, equations, and graphs. Please use that. For the recursive equations, you are not required to do them, but I put them there so that you can try. I will say the recursive for the linear is actually pretty easy to find. The recursive for the quadratic is pretty hard. So it's okay if you don't get it. If you don't, move on and answer everything else. Does that make sense? Yesterday you worked in your own groups, or did I choose groups? Own? All right, so I'm going to give you guys, how much time do you need to finish this worksheet? 10, 15, or 20?
20.
20. Can I get 2 more voices?
Lisa, see, what you guys need, 20, 15, 10.
15, 20, 15, 15, and 20. Let's start with 15. If we need 20, I'll give us 20. You have 15 minutes to finish this with whoever you want. You can use this, join the same group as yesterday, or you can start a new one. 15 minutes. Go.
Hey, Chiqui.
Chiquis, I would ask the ladies to help you get started. Do you need one as well?
So vamos a ver.
¿Qué tengo que hacer?
¿Ah?
¿Qué tengo que hacer?
¿Qué tengo que hacer?
¿Qué tengo que hacer?
¿Qué tengo que hacer? What do I have to do?
Or it's the cool.
What do you think? ¿Qué piensas?
No sé, usted dime.
Yes.
Frecuencia.
¿Qué?
Yeah. Good job.
Oh my God, let me
You're
do it.
substituting numbers for two of the letters M and B. M stands for,
I'm
stands for,
busy.
Y-intercept,
¿Qué tengo que hacer?
numbers in front of them. You've already done
Entonces una maestra me tiene que
it.
ayudar.
Go sit with them
I
and
think
do
you've already
that.
found your Y-intercept.
Okay.
Awesome. Hi.
Hi.
So you're gonna start by reading this, looking at this, reading this, looking at this, reading this, and filling it all out. Okay? Yeah, start by reading. Read, read, read. Now, Janelle?
Yes, dear.
Lotion, hand sanitizer. So, napkins, behind you, right there. Paper towel. I like it. I'll switch it up. Yes, yes. Yes.
You didn't even give me the other one. You didn't even give me
Oh, yeah.
Less chismos, more words.
Not even.
He needs. And then we put Dakota. No? Can we switch on the line just over there? But she's friends with these two. And they understand her. So maybe keep that. Yeah. Whoa. How are you doing?
Oh Lord. I said I have an 8.
Alright, how are you doing?
Still back in the glitch.
Are we stuck? Is that why we're drawing dots on the table instead? She's doing it. No, just distracting me.
No, stay on track.
We are twinning. It's turquoise.
You're really good at that.
She's really good at it. She's like a ninja. Okay, perfect. So, we know that this is not a linear pattern because it is quadratic. Good. 23 is not the right number though, and you need to check your numbers. 7 to 20 is 21. 28 to 63 I believe is 35. But I don't know that the difference
Breaking it
between
down into three separate.
these is 23.
This one, this, and this. So I got one by six, one by one, and one by four. Then I have a 2 by 1, 2, 3, 4, 5, 6. 2, and another 2 by 6. We'll write it out to 2.
So we're gonna be subtracting
So then you're gonna get how much are you increasing by on the
23 the gap in between them, the jump.
3 by 1.
But it's going from 21 to 35, so right? So 21 plus 14 gives us 35. So we're gonna change that to plus 14. Erase that. How are you doing?
Choosing each other first.
12. So the current function for a quadratic is y equals x squared. Write that down and start there.
Okay. 1, 2 by 2, 3 by 3, 4 by 4.
If you don't know, skip it, but also ask your table mates. I'm seeing a lot of people not doing a whole lot. Ask your table partners or get up and ask someone else. You are expected to be doing this, not sitting and chatting.
You know what the formula is?
14. So then how can you use this number, because you're trying to find what right now?
What you were
And you don't want to draw it, right? That's a pain in the butt. So how can you use this number to help you get here? It's 2 steps. Count all the blocks over the y.
Yeah.
Are you good with
So how
this
can you
in
use
here?
this and this to find the next number? Right, we know this is gonna be plus 14.
This is
Okay, so put 4,935.
I walked by like 5 times.
And then how does that number help you find this number?
What you doing? Yeah.
Yeah. Nice.
Yeah, so
Good.
the total in here, the
Six.
total in here, the
What
total
did
in
you
here.
add?
Add all three. How you doing, Juan?
So 14 is our second
How you
constant, our
doing?
second difference, right? Difference.
Can you come
So
over
we know
here?
that these have 14 in between, these have 14 in between, and that's how we know that it's quadratic. How do we find this number using the order value? And then that is one more number equal to. What is, yeah, because it's 63 plus 49
Increasing
is gonna give us
like what
our
are the
fourth
sides?
value.
How much did we increase from 1 to 2?
There you go.
I want.
Find the difference in all the x's and all the y's. How is 7 to 12 changing? How is 12 to
How did
17
you get
changing?
the difference?
Now you have 112. Yeah, so how are you gonna draw your
Quadratic, or you just gonna be, with an x squared?
Well, you know 17 x squared. What can you count by on the
Increasing by
x-axis?
each time, like what am I multiplying?
What should you count by on the y-axis?
Right. So if you wanted to figure out how to solve for like a quadratic equation, start with
So,
this is.
We know that the
You can
equation
see
works
if you put in
when we can
values,
substitute our
what you get.
values
So
and
it's
values.
about 7x
So if you substitute,
squared,
let's start with the
and put
first
one
one, what would you put in
in
for
for
y?
x, so you get
What would you put in for
7x
x?
squared.
Is 7 equal to 1? This one's great. Is 7 equal to 1? Okay, it does not.
So like if I put
7 does not equal
1 into
How
my
could you
x squared
manipulate
here.
this? So that it's plus 6, okay,
Times
try that.
1 squared.
So then now you know it'll work. Now it needs to work with like that. It could be subtraction, multiplication, division, addition.
1 squared. Oh, no, plus, but not plus.
It's the fourth one.
It gives us the 7. You don't need to put plus on it. We don't, our y-intercept should be 0, 0 on this one.
No,
Because
that's
if
how
we
we're
started
doing
with
it.
a size 0,
So should you
we'd
not
have
be
a
able
0
to choose your
on
numbers?
top.
That's what I'm
So
gathering.
your
That's what I'm
y-intercept is
gathering.
right on that. So we don't have a.
So that's, so your
Plus
answer
would
is
always
no,
neutralize
actually
your
two different
y.
groups.
So let's try for here.
Do your
7
work.
times 2 squared. And that gives us 28.
So explicit is what I'm more concerned about. First is really hard, but explicit just means can you write an equation that represents this? That was good. That's wrong for 1. But yeah, just like this. You used y equals mx plus b for that, right?
Alright, and try it for 4.
So what does the b represent? So what is it?
Yeah. Alright, fill in your table there, great. So now we're gonna graph it. This is gonna be your
No, your slope is
If you have
5.
to go all the way to
Right,
112 and the
because how do you get
y's,
five?
what do you wanna go by here for your scale?
I don't even know what number is that.
0 to what? What's your first target? We use 1.
Why is it 5?
Let's try it. If our y is in our
Right, but it's also has to do with this.
3, 4, 5, 6, 7.
Look, slope is 2 numbers. The division of rise and line.
Over here we can go by y, right? 'Cause we do 4.
Rise over rise, 1 over 5 or 5 over 1?
What do you think right here?
It's me, even though you started.
The rise is on top,
Why is it a
which
little
axis
much?
rises?
Yeah, let's try 10. So go by 10 there,
Yeah.
and go by 1s across.
So that's why that's on top, right? 5 divided by 1
That
gives
looks
us.
great, we're gonna skip this
Okay,
section.
so we know the slope is 5.
Can you
How do we
give us
find
some
this?
similarities and differences between the picture, the table,
But
and
you're close, because you're going to the
For the
smallest
equation
x
table.
value.
between this side and the
But
other
it's
side?
not when x
What are
equals
some
1, it's when
similarities
x
and what are some
equals.
differences between
Okay,
the
so
linear
what
and
does
quadratic?
x, y equal when x equals 0? Yes, Jenna?
2, right?
How did you figure that out?
Minus 5.
Nice. Explain that to Enrique, Gabriel, and Geraldine.
What is that?
Find the slope.
We're trying to find you.
It's a different equation. A quadratic function? So did you find, are you talking about finding the equation? So for the quadratic function, and this is new, every function has a parent function. They're born from their parent. For linear, it's y equals x. That's the parent function. For quadratic, it's y equals x squared. Start with this, substitute your numbers in, and figure out how you need to change it so that your equation is balanced. So for example, if I used the first coordinate, I would plug in 7, and I would plug in
When we
1.
think about plus something,
Does 7
there's no
equal
variable,
1?
that's our y-intercept.
No, it doesn't. What or how could you change this equation so that it would be 7 equals 7?
Think about what we can do this for.
I can think of 2 ways.
7 is what we know. We put in 2 first. Yeah, you're gonna try to figure out your equation. It's an investigation.
3 more minutes.
You want to just try to think through it. What makes sense? How did he get that answer? He guessed. I can give him that. Plus 6, right? He tried.
So this is this is correct.
Try it.
Where's your line?
So that's what I was just saying, that makes sense, I think you're thinking, well, we have a point, 0 is our y-intercept.
This point fits. So if our slope is 5 or 5 over 1,
That's
how
the
would
your
we slope?
y-intercept.
So it's going to be y equals slope.
Rise over 5 or
Was right.
You could go
Try
down.
and see if you get your y value.
1, 2, 3, 4, 5.
I divided by 1, so what's 5 divided by 1?
I feel like I'm missing people, so I'm just gonna leave it.
How did you know?
Divided by 1.
Oh, no, that's right.
Yeah, so it's 5x divided by 5. 5x and then we're trying to find that 0.
So you want your line to go up or down. First, the end would just be going up.
That's why we're trying to find
Y-intercept is gonna be 0, 0, because
When
your
you
side
zero.
is 0, has 0 down.
What do you get?
So that's our y-intercept. Our first point on the graph is gonna be down here, it's 0, whereas
Then now you
this
can
side,
grab your.
our first point on our graph, so we gotta figure this out. What would be our y-intercept here? We gotta graph it.
Y equals
And from your.
Okay, that one point. Now, how did you get this?
And then.
And then you-
That's super close. This is from 7 to 28 is 21.
Yeah, when I went to work, it was 0.
I told you 21 and 25. You get it? Okay, put it in calculator.
So put a 0 up here. And think about it. That's why I'm just like that. So change these four to drag. Okay. Y value, x equals 0. I added 1 to these terms. I subtract to get to 0. Subtract 1. Subtract 5.
5 is 12. 7 is up to 5. Your 5.
Your y-intercept is equal to 2. Alright, so that point would be right on the y value. Right, now you have another point you can drop. 1, 7.
2 to 7 is up.
And
5
let's draw a line.
5. 7 to that is 21. And then 21 minus 5 is 16. Hold on.
Now, we wanna make our
because you
equation
can't do
down
that, I
here.
understand.
That's y
You-
equals mx plus y is y, mx plus b, n is equals b, and b is y intercept. Y
This is not
equals
Oh, yeah, we're learning. I thought I said this.
we know this, right? We're gonna rise over our run.
You can't assume this is a run.
What's our rise? Y, we're increasing by.
If you wanted to do that, which you can, and how would you do it? We know that this is actually,
This is actual. When we put it in here, we don't have to write over one, right? Because we know anything that doesn't have a number, we can put it
this is
over. Our m is gonna be,
so 21.
and now we know our y intercept is what?
Like the one that.
Our y intercept is always just b.
You go like 8.
And we have a point. I'm writing it down, it's not really.
7.
So that was two was our y intercept.
7
So we
minus
just put the
7.
y value for our y.
Right, what's the difference between 7 and 21 is 14, and 21 and 31 is 14. Right, so you use 14 to go backwards to figure out what the difference is between these two, which is 7. So then 7 minus 7.
Like we did on the other side.
So you have to use up to 2 steps versus this side, which was 1.
Scale, plot the points.
So then now use these numbers to help you figure out what the 0, 0, 0.
And you're gonna have here, so 35 is across 2 y per usual on the. She wants you guys to figure that out, because look at the scale. So we're gonna have ones on the bottom because we're going up by ones in the x values, but on the y value, what should our scale be? Since we have to go all the way to one.
So I think it's easier for me to focus on the differences between them. They both have, I don't know,
We'll
maybe
try 5, we probably won't get there, 5, 10, 15.
they both have constant rates of change
Let's try 10,
in
10,
different places, right? So linear
Definitely gonna work with them. Alright, so our ones, x's.
I think like what I think is the most similar about them is that they both have this, but in different spots, right? They both have x's and y's, but different rates, right? Do we need more time? How much more time do we need?
Yeah, I'll wait.
5 more minutes? Thanks, Bernie.
Not the first day. I don't see any eraser in here.
Who needs help?
What do you have for?
Who needs help?
Okay. Here.
Whoa.
Y's have to go up to 1, so we don't have to plot 2 but at least 1. So what would
That
our
should go
y
here.
be?
However, I like your thing, because now you can count it.
Take it.
Yeah, try to adjust those two together, like 5, or does that make sense?
14 hard.
What do you want?
Okay, so
Okay,
that's
so
easy
option
enough
has
to
to
do.
be-
7's really clear.
This is the.
We wanna go up by how much here? 10, 20, 30, I would go by 10, right?
But I've been showing you, so
We're practicing
for
one
here,
here,
this is the 5,
a 10 or
and it
2.
looks like this, it goes right through the center, in that direction. Up one,
Square, so the quadratic.
For quadratic, the parent function is y equals
Math
x.
Super close.
So I start
So
here,
try it.
and I
Put
say,
your
okay.
x value in,
Gotta make
so
these numbers
what do you get?
Plus
Plus 0 is correct.
I know that I have the right equation when I plug in my coordinates, and the equation's
1
down.
is 10 actually.
So I'm gonna plug in my first coordinate. For the y, I'm gonna plug in 7, and for the x, I'm gonna plug in 1. And I ask myself, does 7
What do you got?
equal
14x.
So I
14
plug in
times 1 squared.
7
Is that
doesn't
gonna
equal
give us our
1,
answer?
so I know that this isn't the final
That looks
equation.
amazing.
And I think to myself, how could I make it so that it's 7 equals 7? Well, I have two options. I have 7 plus 6,
1,
because 1 is 6.
7, yes.
Or
Okay,
I
I'm
can
gonna
multiply
multiply
by
by 7. I do
7.
every single time. So put
Why?
it here.
However, if we start from the next 22 and the next one, the
I've
next
been
one
did this
also.
once.
So that's where I was. You want to add it?
Now, 2 and 28.
Okay, we'll do that.
2,
These are both
Do you need
pretty.
just right under the 30.
Same thing, 14.
Claire, y equals x squared is quadratic. So we start with this and we plug in our numbers and want to get balanced equations, meaning 8 equals 8, 7 equals 7, 9 equals 9, whatever. So you know, that's how we know the function matches the amount.
And I can put 2 in for x.
So we can start with that, they're nice and small and easy, right? So the 7, so I plug in 7.
2 squared. That's not supposed to be straight, right?
28.
No, so I know.
Yeah,
that
try the next one. See, that's nice.
That's, so that's my
So
point.
these
Let's
ones
do
are
it.
eight.
Plug in these numbers, these numbers, these numbers.
Hey.
I got 100.
Yeah, Claire.
Nice, now the, correct.
2 more minutes, who needs help?
We need to put these points. All the points of size 1 is gonna be your x value, size 2.
You got it? Janae, you need help? So, to me,
Think about it, you have to process yourself. See, that's why we're doing this, we want you guys to come to our new It takes a little practice, but now it's like, wow, click, smash check. Elizabeth, Catherine. Elizabeth, what's up? I'm here, waiting. Hey guys, it's not that easy, just like I just told them. I'm not gonna give you the answer. What's the first difference here? 28 minus, okay, write it down please. They already have the second difference. So we have to have a squared in our equation, right, because it's quadratic.
Word.
So our equation's gonna start with y equals x, something x squared, plus what?
Y equals x squared. Okay, so all functions have
Right,
parent functions.
so let's write that down. Y equals x squared plus what? Our 0, 0, remember that's our y-intercept.
Parent functions, y equals x.
What's our first point?
Here, we add all this other stuff.
Our y-intercept, what x equals 0, what is y? On this graph.
Quadratic, it is y equals x.
Look at the other side. Our y-intercept here,
We know that we have created the correct equation.
when x equals 0, what's y?
And get the
Okay,
same.
here, right?
both sides.
So on the other side, when the first shape is 0, size 0, we don't have any boxes, so it's 0, 0.
If I plug in 7 for y, and 1 for my
How did you get that?
is 7
Okay,
equal
I get that, but you can't do that because we have a quadratic, so it's our second. So thinking about our y-intercept is gonna be 0.
How could?
So it's gonna be something x squared plus 0.
So that the equation is
0, 0. Because if we look at these shapes, size 1 is, how many boxes? 7. Size 2 is 28. But if we go the other way, size 0 is 0. We don't have anything to start with. I can't draw a size 0 because there's no boxes, right? So we wouldn't have anything. That's why we started our graph down here at 0, 0. That's our
What could you
first
put on
point.
this side? You can add
Does that make
7
sense?
by any number.
Like you can't have a size 0, 2.
Maybe that's
And
a
in close is
function.
stupid to say size
That
0
would work,
because
right?
it's really not a thing. You know, you can't take 0 from 0.
The next one.
0, 0. So size 0 on
You
this,
plug
there's no
in
boxes.
20 here.
If you drew size 0, that's why this is 0,
And you
0,
plug
that's your
in 2
starting
squared.
point. So now we have to figure out what we're gonna put in front of the
2
x
squared
to make
gives
our
us?
slope. That's what you guys should try in the calculator, as a guess and check. What you can do is put in a number for x, one of these, and see if you get the y. Y equals whatever x is plus 0. So let's try putting in, let's say 2.
Instead of adding
2
6.
times
What
1
else
squared
could we do?
plus 7, what does that give us?
Or just subtract.
Why are you waiting? Exactly. You
So
should be
1
doing
minus
it.
8 would give you-
Put in the calculator.
Oh my god.
So maybe it's not additional subtraction.
What about when x equals 0?
times, so you're saying
Okay,
equals
so why?
7 in the front? So 7 times x squared, which would be 7 times.
Okay, so that can't be it, right? Because we want it to equal what?
Okay.
Right, so let's try something else. What did you guys put in 2?
That 7 there,
This one will be 0.
By the cross.
would that balance out equation? Does that mean
You're going up by what here?
we're gonna go over again?
So how can I go the other way? I'm going down now.
That's right.
Well, if I'm starting with 7. 7 minus 5
You all
gives
start
me
shooting
what?
what? You mean what?
Close.
You guys both have all star?
That's your starting point.
What does that
On
mean?
this graph.
Are you gonna play a
No,
final game?
that
What's
is
that
the
everyone?
X.
When?
Y, X. Keep trying.
What time? 5:30?
0.
Next Friday? You guys remind me?
Okay, but you're getting.
Are we ready to go over this?
So the answer, think about it, if it gives you the same answer.
I heard yes.
What do you have here? What are you trying to get
5
to?
more minutes, they're wasting time talking, you guys are not doing anything.
You
Lindsay's
really
with me.
I'm trying to recognize it.
Okay, go back to your seats. Yeah, I'm seeing a lot of time being wasted by most people. Sorry to those of you that are working, but let's go over this. Back to your seats in 10, 9, 8, 7,
From what? Putting in what?
6, 5, 4, 3, 2, 1.
Yeah, how did you get that? Where did you put it in? 5. 1, 2, 3, 4, 5. Increase of 5. You can always look over here too.
Gabriel, where are you gonna go? If you had asked me, I might have said yes, but because you assumed that you could stay there, I have to say no.
I asked you before.
7 times, instead of 1, put 7
When I
times.
said everyone go back to their seats, that was your opportunity to say yes, please.
7 times 2 squared. You don't even have to put it on 0 because always
I
have to
did.
be
I
safe.
said, and I said.
7 times 2 squared, right?
Yeah, you're arguing, definitely.
Well, that's one.
Right. Okay,
Yep.
so let's go over this. I'm going to call on people according to our alphabetical attendance. How about that?
Yeah, you're right in the beginning.
Whose last name comes first in this
Oh,
class?
dang.
Whose last name comes first?
Last name.
Ariana?
Ariana.
Ariana? Ariana?
It is Ariana. Good job. Alright, how does it make you feel that everyone knows that? Alright, Ariana, then it'll be Abel, Edwin, Fernando, Jenna, and then I'll just keep going down the list, but there's your heads up, so be ready to answer. Marco has started a new blog about sports at Imagination High School, mascot the Fighting Unicorns, as he has decided to call Eyesight. He created a logo for the website that looks like this. He is working on creating the logo in various sizes to be placed in different pages on the website. Marco developed the following designs. Here they are. What would the equation table and graph look like for the logo pattern? So Ariana, can you please tell me what numbers you put in your table and why? Thank you so much. Where did you get these numbers from? So did you find out that there was a +5 pattern in between and you used that? Or did you count each block? Nice. Awesome. Thank you so much. Abel, Ariana already did some heavy lifting for you. She said there's a +5 pattern in the number of blocks and a +1 pattern in the x values. So that means what type of function is this? Linear. Thank you so much. Edwin, can you please help me with
graphing my points and telling me how to graph just the first two because the other ones won't fit. Where do I start? How do I move my pen? Where do I plot my point? Use words like left, right, up, and down, and give me numbers.
Sometimes you have to go up to.
Why do I go up 2?
It's two.
Why didn't I go left or right?
It's wide.
It's the y-intercept, but also because?
Zero.
Good. How do I plot the next point?
Move one to the right. And then go 7 left.
Thank you very much. What do we call the starting point? Say it again?
Origin.
Origin. Can you pass me a protractor in there? Thank you for passing it to me that slowly. Okay, and there's our beautiful line. Next person, Fernando, did you get your formula, your explicit formula? Nice job. What formula did you use from last year to get this? Nice job. Carla, what does the M stand for? And what does the B stand for? Nice job. Enrique, where did the 5 come from for the slope? Right? How did we get 5? Did we just use this number or did we also use that number? Both. Because it's rise over run. Which of these is my rise? My X or my Y? Good. Y is the rise because it goes up and down. Well, this is the run. So we got 5 over 1, which is just 5. I want to point this out because a lot of us think that it's just the change in the Y value. It's not just the change in the Y value. It's the division of the change in the Y and the X. Because sometimes this number won't be 1. Okay, good job. And then, Tamia, how did you get 2 for your equation? Since this actually wasn't given to us, even though Ariana gave it to us, how did she find that, or how did you find that? The y-intercept, but we got this how? If we only had up to these numbers, right, how could we have figured out that the y-intercept was 2? Say it again? Subtracting what? 5 from 7. So you went backwards. You went the other direction. So if we go backwards 1 and 5, we're going to get 0 and 2, and we know this is our y-intercept. Nice job. All right, the recursive formula, we're going to save that for the notes unless anyone would like me to go over it right now. Anyone? Okay, backside. So, Marco decides to experiment with making his logo blockier so that it looks stronger. Here's what he comes up with. Assuming that Marco continues with the pattern as it has begun, draw the next figure, size 4, and find the number of blocks in the figure. So I saw a lot of people drawing this, and I just want to show you how I drew it, because there is a faster way. I'm noticing that there are 3 shapes in my mind. I can see a rectangle here, a rectangle vertically, and another rectangle parallel to the top. So what I did was I drew my rectangles, and like Alex said, he said it's increasing by 1 on each side, right? It went from 1 to 2 to 3. So I know the next one's going to be 4, right? Same with here, 1, 2, 3. So the next one's going to be 4. Up here, it's going from 3 to 1, 2, 3, 4, 5, 6, 9. So I know it's going to be how many lines going down? 12, right? So I know I'm going to go 4 across, 1, 2, 3, 4. 1, 2, 3, 4. And then I know each of these is gonna have 12 going down. For each of these boxes, it went by 1, 2 by 2, 3 by 3, so the next one's gonna be 4 by 4. So we have our 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then again, 1, 2, 3, 4. 1, 2, 3. That took me less than 30 seconds.
Let's keep going.
Huh?
Let's keep going.
Huh? Joke killed. Okay, so that's how you could do it, and if you wanted to count it, you could. If we wanted to count the boxes, how many is in each of these corners? 16. So we know this is 16, this is 16, this is 16, this is 16. 4 by 4, 16, 4 by 4, 16, 4 by 4, 16. And what can we do with all those numbers? Add them up, and what do we get? You guys already have the answers, so you don't have to add them up technically.
Wait. Oh,
112.
I forgot it was 112.
Oh boy.
112. Okay, but if we don't want to do that because it's a little time consuming, we can also use the table. So, Tomas, can you please tell me the numbers you put in the table?
For X, I put 1, 2, 3, 4, 5, 6.
Great. For Y?
7, 28, 63, 112, 175, 252.
And what was the last one?
252.
252, thank you. Nice job. Tomas, actually. Yeah, Tomas, can you tell me how you figured out 112 in our table?
Because I know the comma second difference.
Great, can you explain more step by step?
I first did 28 minus 7,
Okay,
which gave me 21,
okay,
and 63 minus 35.
okay,
Well, 63 minus 28, which gave me 35.
okay,
Then I did 35 minus 21,
okay,
which gave me 14.
okay.
And I added 14 and 30. 14 and 35, and then I gave me 49, then I added 49 to 63.
Does anyone want me to go over that one more time? Great job. Great explanation. Does that make sense? Why do you look confused?
No.
Okay. So, that is how we figure out the pattern in the table, and then if we're gonna graph it, I'm going to use my X and my Y axis, or I'm gonna draw them, and Juan, what should I count by for my X values and Y? What should I count by for my X values
1
and Y? You're not Juan.
by 1.
Y. Great, that's really small, right? What should I count by for my Y values? There's more than one correct answer. 10, that's what I counted by too. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, which makes sense because there's 17 blocks. Great. Then I'm going to plot all of my points, and you should get a graph that looks like this. You should have gotten a curved line.
Yeah, just ignore her like extra squiggles. She had it.
Ignore that. Ignore that. You should just have a curved line.
Okay, we connected up.
All right.
What's up, guys?
Now, for the explicit formula, which I'll go through more so in our notes tomorrow, every function has a parent function, okay? For linear, the parent function is y equals x, and it looks like this, where it goes right through the origin. For quadratic, it's y equals x squared, looks like this. For cubic, which is what you'll learn next year, it's y equals x to the third, and it'll look like that, right? Everything has a parent function, the original function. So when we are asked to create an explicit formula, we want to start with our parent function. From here, we want to use our numbers that we have in our table to see if it balances the equation. So if I wanted to use or start with 1 and 7, I know that I'll plug in 7 for my y and 1 for my x. Does 7 equal 1? Does 7 equal 1? Is this a balanced equation? No. So that means I need to manipulate my equation. Some people said plus 6, right? And that worked for the first one. But when we did the second one, 2 and 28, we plugged in 28 equals 2 squared plus 6, 28 equals 4 plus 6, 28 equals 10. That didn't balance our equation. So that couldn't have been it. So plus 6 didn't work. So what is another equation we could try so that it does balance our equation? 7, what was 7? Multiply, right? So if we did y equals 7x squared, let's see if our numbers work. I'm going to start with 1 and 7. 7 equals 7 times 1 squared, which is 7 equals 7. Is that true? Great. Let's try another point. We always want to make sure it works for at least 2 points. Otherwise, it might just be a fluke. 2 and 28. I'm going to plug in 28 for my y. I'm going to plug in 2 for my x. So again, I'm using this function. 28 and 2 go here. Keep the 7. 28 equals 7 times, what is 2 squared? 4. 7 times 4 is 28. Does 28 equal 28?
Yes.
Yes, it does. So that means this is our explicit function, y equals 7x squared. Right?
What's our y-intercept on this graph?
And how could we figure it out? How'd you get 0, 0, Jenna? How'd you get 7 minus 7? You know that 7 plus 21 gives you 28. Work backwards, you're going in the wrong direction. You know that 21 and gives you 7, right? 21 take away 14, right? Because we're going in the opposite direction, gives us 7. And that 7 gives us, right? So going forwards, we had to do addition, but going backwards, we have to do. Does that make sense? Yeah? All right, lastly, differences. We're just focusing on differences for the equation, the table, and the graph. I'm going to call on Juan, Lindsay, and Cheekies. Equation, table, graph, in that order. Juan, Cheekies, Lindsay. Juan, what is different between, and you can look at the whiteboard, what is different between the equations of linear and quadratic functions? One big difference.
You're not asleep.
The exponents, right? What is the highest exponent for linear? 1, and what's the highest exponent for quadratic? 2, it's on the board. Cheekies, what is the difference between the tables? Or no, I'm sorry, Lindsay. Lindsay, what is the difference between the tables? Nice, thank you. I'm gonna put CROC. What does CROC stand for? Nice. And Chickies, what is the difference between the graphs when you look at the graphs?
What's the difference between this graph and this graph?
Both curves are on the straight.
Straight line for linear, and what is it called for the quadratic? Huh? Because of P.
Perusra.
With the P,
Yes, say it.
not problem.
Parabola.
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 Oh,
These girls
right.
were holding each other accountable up here.
I
the
love
whole
it.
way.
Holding each other to high
Yes,
expectations.
love that. Love to see it,
Wonderful.
ladies.
Okay, can someone please collect all the investigations? Who is gonna be helpful and do me a big favor?
Denali.
Yeah.
Janelle, come on, help me out. Miss Davis, can you press? Stop.
Like and subscribe.